Our CAT teacher is going to teach you cosine similarity and cosine distance, how it is used in data science. We'll look at some theory and then we'll move into Python code. Let's say you are a data scientist working for some financial company where on a Google Drive you have a bunch of financial documents. Now you don't know for what is the company associated with each of these documents. But when you open the document, when you read it, you can kind of figure out that this is probably about Apple. Why? Because iPhone is mentioned so many times. So when you're reading about Apple financial report, they might mention Galaxy as well because that's their main competitor. But here the ratio of iPhone to Galaxy is iPhone is mentioned 3 times, Galaxy is mentioned 1 time. So overall you see iPhone occurrence much more than Galaxy. If you have a Samsung document, of course Samsung company's document will have more mention of Galaxy than iPhone. Now, let's say new document comes in and you don't know what is the company associated with it. Here you can again count iPhone and Galaxy and you find that iPhone is 6 times mentioned in the document. Galaxy is mentioned 2 times. Looking at the situation as a data scientist, you can figure out a simple formula that whenever a ratio of iPhone to Galaxy is 3 to 1, it should be an Apple document. So now you can auto annotate Apple as a company. This is a common problem in financial institute where you have a document and you want to tag some metadata to it, and we can use some automation, some rules, some coding to auto annotate. You can manually annotate it, but using this particular formula you can automate the annotation process. Unfortunately, things in real life are quite different. In our document, there might be a mention of iPad. Google Pixel is another competitor. So now how do you come up with your formula? Maybe you say, okay, iPhone to Galaxy ratio has to be 3 to 1 and iPhone to Pixel ratio has to be 3 to 1 and iPad to Pixel ratio has to be 2 to 1. Well, that's too complicated. My baby got confused. Well, vector mathematics comes at rescue. This thing can be presented as a vector here, and using vector mathematics, we can figure out document similarity. Let me go back to the simple case that we saw before. How do you represent this as a vector? On x-axis, I have iPhone word count, y-axis has Galaxy word count. So you see 3, 2, 1. And this is the vector. Vector has magnitude and direction both. And when I have my yellow document, iPhone is 6, Galaxy is 2. Now, look at the angle between these two arrows, blue and yellow. The angle is 0. So the angle determines the document similarity. If the angle is 0, it means documents are very similar. You might have another green document, iPhone 5, Galaxy 1 time. Here the angle is still not that high, it's a little bit of an angle. So you can say these documents are still similar. But when you have a Samsung document where iPhone is mentioned only once, Galaxy is 4, you see the angle is much bigger. So when you have a bigger angle, you can say these documents are not similar. Meaning if for yellow arrow I know company is Apple, for blue arrow, I can say company is definitely not Apple. Versus if I have a green arrow where the theta 2 angle is much closer to yellow arrow, you can say green and yellow documents are similar whereas blue is not similar. Let's say the angle between these two is 17 degree. You can use this angle to define document similarity. One thing you can say is document similarities is 17 degree. I mean, when I say that, it doesn't sound that obvious or intuitive. It's not a good way to represent similarity. What if I can present the similarity between some number, between let's say 0 to 1? When I say document similarity is 0.9, which means they're 90% similar. If the document similarity is 1, they are very similar. If it is 0, they are very different. Okay, so how can you transform this degree angle into a range? Because that range seems like a good convention. You just take cosine. If you don't know about sine cosine, I made a previous video previously in the same series, watch that. But cosine of 17 is 0.95. Now see, my convention is much more obvious, much more easier. I can say document similarity here between green and yellow vector is 0.95. Hooray! All right, now cosine similarity is nothing but a cosine of an angle between the two vectors. And the great part about math is we looked at a very simple scenario of two-dimensional vector. In real life, you will have 100-dimension vector. And these dimensions are basically the features. So your document might have 100 features, and you can present those as a vector, and you can still do the math. See, that's the beauty of math. You cannot visualize 100 dimension, but the math will continue to work okay. The academic formula is between a and b, these are the two vectors, and the cosine similarity between these two vectors is dot product, which is a dot b, divided by magnitude of a, magnitude of b. And a dot b is usually a b cos theta. So, it is cosine similarity is nothing but cos theta. All right, now if you have arrows pointing in the same direction, then the cosine similarity is 1, which means those arrows, those vectors, those documents are quite similar. If they are at 90 degree, means the similarity is 0. They are very different. And if it is 180 degree, similarity is -1, which means they represent opposite concept. Now cosine distance is a very simple concept. Just it is used to represent the same thing. It's 1 minus cosine similarity. So here, when two arrows are pointing in the same direction, when you're talking about same vector, the cosine distance will be 0. So when you say distance is 0, which means they are similar, they are closer. That's the only idea behind cosine distance. When you have two vectors at 90 degree, cosine distance is 1, which means they are very different, and cosine distance is all represented only in a positive space. That's why I'm not talking about that 180 degree case that we saw in a previous slide. Let's write some Python code now. We'll be using Python's sklearn module for importing cosine similarity method here. And when you have this method, it expects two vectors, and those two vectors are going to be, the case that we looked at for Apple document was 3 1 and 6 and 2. So let's see what is the similarity between 3 1 and 6 and 2. So 3 1 6 and 2. Now this method expects two-dimensional array. So you have to put one additional array here. I mean, that's the signature of the method. You see, similarity is 1, which means the documents are very similar. And if you find a cosine distance of the same thing, it's going to be 0. Cosine distance, so this is two-dimensional, okay. See, 1 e raised to minus 16, this is very close to 0. Okay, now if you find out a distance between, let's say, these two documents, 3132. See, they are iPhone 3 times, Galaxy 1 times, iPhone 3 times, Galaxy 2 times. Still, they both are Apple documents. So there is an 0.96 per similarity. One similarity means they're very, very similar. Now let's look at some real documents. So I'm going to create some variables here with financial document string. So you can see the first one is iPhone, Apple document, Samsung, Samsung. Okay, and what you can do is you can create a pandas data frame. So I'm going to import pandas here, and we create a pandas data frame, and in the data frame we are going to hard code some arrays. Okay, so what are those records? In the first document, you see iPhone came 1 2 3 times, Galaxy is 1 time. Okay, so iPhone 3 times, Galaxy 1 time. Similarly, I have pre-counted the iPhone and Galaxy word count in remaining documents, and that's what it looks like. Now in the index, I want to supply the document as an index. So instead of 0, 1, 2, 3, I will say, okay, doc1, doc2, doc3, and my data frame will look like this. So it says document 1 has iPhone 3 times, Galaxy 1 times, and so on. You can clearly see first two documents are Apple documents, and second and third documents are Samsung documents. Now, when you do something like this, it returns you first document, but it is two-dimensional array or a data frame. And our cosine similarity function expects that data frame, and that's why we are doing this. Otherwise, I would have done simply this. I want to compare, let's say, uh, document 1 and document 2. So I would have done this, right? But see, it expects two-dimensional array, and that's the only reason I am doing this kind of range. Okay, we are getting some error. Let's see. Oh yeah, this is a syntax error actually. It has to be this way. See, they're very similar, 0.94. So we can say both are Apple documents. But if you do the same thing with, let's say, document 1 and document 3, they are not that similar. See, 0.6. Why 0.6? Well, let's compare doc 1 and doc 3. See, 3, 1 and 1, 3. There's some similarity, but if you do doc 3 and 4, let's say, then they will be more closer to 1. See, 0.98. And now for the same documents, if I do cosine distance, it will be 0.01. So cosine distance is 1 minus similarity. So if you add these two numbers, they will add up to 1. That's all pretty much I had. If you want to do the same thing in TensorFlow, then TensorFlow has this particular function that you can use. I hope you like this video. If you did, please share it with your friends. Thank you.